Hello, everybody. Welcome to Mad Science. I am Professor Axion, and I am here to show you guys some really cool experiments you can do at home, which would be awesome because we want you to do science. Yes, we do. First of all, though, if you do an experiment and you send us, if you do an experiment and you post it on social media, if you guys do that, and you link us and two of your friends, we'll put you in a drawing here. There we go. Social media, add us there, tag a couple of your friends, a picture of you doing some science. We'll put you in a drawing to win a robot. It's a super cool robot too. We have a drawing every week. Usually on Mondays. I say usually because sometimes Mondays are a holiday. But we have a drawing once a week, and every week somebody out there is going to win a robot. It could be you. So let's get started. Here's some cool things you can do at home. Now, first of all, ask your parents first. I know, but seriously, guys, ask your parents first. You don't want to get a mess. You don't want to get in trouble. And also sometimes things are high. You need somebody taller than you to reach things. Anyway, first thing we're going to talk about are vibrations and sound. Sound moves by vibration. Everything is made out of molecules. Everything's made. These glasses made out of molecules. This food coloring, molecules. My hair, molecules. The air, molecules. So what happens is there's a sudden movement in air, like that, and that makes all the molecules around there start hitting each other, and that sound moves across. Now we can play with this. I have here 5 glasses. I'm going to put a little food coloring in each one, different colors, because food coloring is awesome. We like food coloring. And there we go, and another one. Now, I'm going to put a different amount of water in each glass. And we're going to see how that affects our vibrations. So I've got my picture here. We are going to go with a 1/4 cup for the first one, and this will be the blank one, the clear one. Ooh, that looks like a lot. We're going to redo that. That is too much for this size of glass. So I am going to do a little less. I'm going to do more like it that much. There we go. Now for the next one, we're going to do twice that. There we go. Yeah, that's about twice. And I say about, try to be precise when you're doing science, as best you can. Now we're going to do the same amount, same as that, only this much more. So usually in a bigger glass, I would be going, wow, that's a lot. A 1/4 cup, a 1/2 cup, a cup, a cup and a 1/4, and a cup and a 1/2. Let's see if we can go that far. Let's see, there we go. And what this gives us is more, well, let's talk about it. So when molecules go through the air, it's super easy, right? It's air. Whoosh, whoosh, sound travels. Sound travels slower through water because water is a little bit denser. As you can see, you can't breathe water, can you? So we have different amounts of liquid in each cup. And we're going to see if that's going to affect the sound. I have a couple of different things here to use because you guys will be doing this in your kitchen, and I want to make sure you have similar equipment. So this is a piece of wood, maybe a ruler. You can also use a wooden spoon. I also have a plastic spoon, and I have a couple of dowels just in case. So let's listen. Did you hear it? We'll go the other way, and this time we'll use our spoon. So which one is deeper or a lower sound? Which one is higher? Let's try this, like drums. That was fun. So as you can see, the different amounts of water made different sounds in our glasses. For the record, the color of the water does not matter. That did not affect the density of the water enough. But for you to do at home on your own, what if we used different types of liquids? What if you used soda or milk or oil or pudding? Would you get different sounds? Think about that, and then what you do is you make a guess, and we call that a hypothesis. And when you make a hypothesis, you see stuff, you come up with a question, you guess, and then you experiment to see if you're right. That's the scientific method. So put something else in your glasses and see if that affects the sound. Pretty cool stuff, I think. So that was musical. One more time. And it really is a lot of fun. And I am going to move some of these down for our next experiment. Okay. Just making sure I've got all the right stuff here. And we talked about how water is denser than air, right? That's why water is liquid, because those molecules are closer together. Air, the molecules are further apart. And solids, they're right up next to each other. But different things are different densities. Okay, so density is how, when two things are the same size, but one is heavier. That means it has more molecules in the same amount of space. And that's interesting. So we're going to talk about density. For example, real quick, think about a foam ball and a metal ball. Which one would be heavier? Which one would be lighter? Heavier would probably be the metal ball, because foam balls weigh basically nothing. Even if it was hollow, the metal ball would probably be heavier because metal is dense and foam is not. No. Okay, back to this. So I'm going to get rid of some of my water here. I'm going to make these about half. I'm going to add some water here. There. I'm going to take out a little bit more of my blue. There we go. So what I'm going to do here is I'm going to make my yellow water more dense than my blue water. And I'm going to do that by adding salt. And in order to get this to work right, we need 10 teaspoons of salt. We're really going to salt this thing up. So here we go. And this can be pretty messy. Again, why you want to talk to your parents. 3, 4, 5, 6, 7, 8, 9, 10. That is a lot of salt. You will notice I am putting the lid back on my salt. Always replace your lids. I did not replace them on my food coloring. Yes, I know that. That's because I'm going to use them again. But whenever you're experimenting, it is best to replace your lids. Now, while I'm stirring this, let's talk a little bit about safety, shall we? Now, because we're doing kitchen type science, stuff that you can do in the kitchen, I'm not wearing gloves or eye protection at the moment. I am wearing clothing protection in my lovely lab coat. But usually you should be very careful because, you know, you got to protect yourself. And if you are experimenting with something and you don't know if you're allergic to it or if it's going to hurt you or something, wear gloves. Wear glasses. You can wear sunglasses, goggles, swimming goggles, scuba goggles, whatever. Just keep yourself safe. Try not to splash in your face. Try not to get it on your skin. How are we doing with this? Good heavens. It's still going. Okay. And we're going to give this a chance to dissolve a little bit. I may have reached saturation, which means it can't possibly take any more salt molecules. So I'm going to set that to one side. Back to our fresh water. Here, we're going to add a little bit of oil. Let's see, hang on a second. I'll make sure I've got everything. There we go. And I'm going to gently add oil. It looks pretty cool, doesn't it? And we're going to keep going, keep going, keep going. I'm going to need some more oil after this, aren't I? There we go. Now you'll note the oil is floating. That's because the oil is buoyant. That's another science word. Everybody say buoyant. And buoyancy is what we say about how well something floats. Density is how many molecules it's got in it, how much it reacts to gravity, which is weighing it. That's density, that's mass. But buoyancy is things that float. And sometimes that can be interesting too, because you'll see it's just floating away up there. And that's going to allow us to do some super cool experiments. Still, stir, 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 stir. And then we are going to go ahead and pour this thing in to there and see what happens. Okay, let's try it. I'm going to pour very, very slowly. I'm going to tip it and pour. And let's see what's going to happen. Okay. Well, I made a little bit of a mess on my tray. That's why I'm using it on a tray. And as you can see, I've still got, I poured it a little bit fast. So where it's green is where the two waters mixed, but you see that blue right there? That's the fresh water sitting on top of the salt water. And if I could have poured that even more slowly, we would have gotten more of a yellow-blue situation. So that takes a lot of practice. Now the reason, why is that happening? Because the salt water is more dense than the fresh water, so it comes to the bottom. Then I've got my little strip up here of the fresh water, which is more buoyant than the salt water, and then I've got my oil on top of the fresh water. because the fresh water is denser than the oil. See, all kinds of cool stuff to figure out. Now, the two waters mixed because they are miscible. That means they are two items that will mix together. If we just left this alone, eventually the salt will evenly disperse itself about all the water. But the oil is not miscible, it is immiscible. And that means oil and water, not gonna mix, not gonna do it. Without something to force them to work together, these two, this will stay like this forever. Now let's try a couple more experiments. You can try dropping things into it, see if they float. Ooh, boom, right to the ground, or right to the bottom. How about you? All right. How about a bead? Oh, interesting. Interesting. The bead is heavier than the oil, but lighter than the water. Interesting. And you can try floating different stuff. You can take bits of tin foil and mix them up and squeeze them really, 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 really tight and see if you can get it dense enough to go all the way to the bottom, or if that's going to float, because tin foil is pretty light. Pretty cool. And one more. Oh, I did the plastic ones. Let's try. Nope, even the metal one. Let's just say that paper clips sink. They sink good. Okay, let's move on to another experiment, shall we? Let's talk a little bit about the ocean. So I have here a tub with some water in it. And this is warm water from the tap, okay? Doesn't have to be super hot, but the other water does have to be cold. So what we're going to talk about here is convection. And that is the movement of, well, air and water. And it's, in this case, we're going to do it based on temperature. So like I said, warm water down here, right? We're going to put a couple of drops of red food coloring over here. Boop, boop, boop. All right. And in here, I have some blue ice cubes. We just added some blue food coloring to some ice and let it chill overnight. So you see how that red is moving? Now over here, we're going to put the cold. I'm going to be really careful to try not to mix it up. Be gentle. And you can see, you can also do this if you just can't get any ice cubes. Oops. You can do it with super cold water that is dyed blue. A couple more. Get ourselves a good color going. Very cool. And now you can see the temperature reacting to each other. I'm going to hike this up again. Wah! And you can see it all moving around. And this is the kind of thing that is actually happening in the ocean all the time. In lakes and ponds too, but mostly the ocean is where it's really dramatic. You've got your cold water, which, okay, ice floats, but cold water is going to sink. So that blue is going to start going down. I'm going to add some more red food coloring. See what's going on, because it started moving around a lot earlier. And the red, the warm water, rises. Food coloring, however, is denser than water. That's why the red is going down right now. But you can see how it all starts to react to each other. Let me lift it up again. Like that. See the colors reaching out to each other? Again, what this wants to do is it wants to smooth out. It wants to even out. So where it's warm, it wants the cold, and where it's cold, it wants the warm. Do I have any more? Oh, I do. A couple more blue ice cubes on this side. There we go. That's just going to keep going for a while. And it all kind of depends. Now you want to be careful, don't stir this. If you watch it. Yeah, see? The red is staying up at the top, the blue is starting to hang out at the bottom, and it's all slowly going to mix together. Okay, I've got one more super cool experiment for you guys. Let's put this over here. You've probably seen a bunch of different types of making lava lamps. I've got another one for you. Let's see, I need one of my glasses. There we go, about half full, very good. And I'll pour that out a little bit. So I've got some colored water again, and I'm going to add oil, which will bob to the top. We already said that. How much do I have there? Let's give ourselves a little bit more. And a little bit more. Because we want a decent, there we go. All right. Now, I'm going to take some salt. Let's make sure you can see that. See the red water down there, and then you've got the oil on top, right? Okay, I've got some salt, and I'm going to pour it over the top. Do you think the salt's going to float, or do you think the salt's going to sink? Let's find out. And salt, 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 salt. Salt, 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 salt. There we go, there we go. There we go, there we go. There we go, there we go. There we go. Okay. Can you see it? There we go. The salt has pulled down some of that oil down with it, and it's slowly letting it go back up. Bloop, like that. So the salt was so heavy that it actually brought down some of the oil with it. And you get a slow kind of bloop coming back up. I'm going to put some more salt in here because it's awesome. Salt, 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 salt. Oof. And then it all goes bloop. And there you can see it. It's pretty cool. Even better when I have my hand behind it and you have a little darkness, huh? Now these are all experiments that are really good for observation. Observation is one of the coolest ways to do science. I know it sounds like you want me to just stare at stuff, but no, seriously, watch it. I mean, I could look at this for 15 minutes easily, just it slowly going back up again and bouncing up. And observing the different ways that materials react to each other in nature. It's amazing. It really is. So those were 4 experiments. And again, feel free to play with them a little bit. I mean, we did this with water and oil. Would it be different if you used a fizzy water? I don't know. Maybe, maybe not. With our ocean here, you see we're starting to go pretty purple. Look at that. You've got the hot water on top, you've got the cold water on the bottom. Now, would that be a different if we added salt to it, like the actual ocean? Would salt water still react the same way? All of our musical things over here, do you think they would change if they had different liquids in them? And finally, our density stacker, which I still have a little bit of blue there. You could try seeing various and assorted things that could, well, see, would it float on top of the oil? I haven't found anything that floats on top of the oil. Again, we want you to take pictures of yourself doing science. If you are not comfortable doing social media, that's fine. Just email it to us. We won't put it out there unless you give us permission. But if you guys do put it on social media and tag a couple of friends, you can go into a drawing for that super cool robot. There's that again. And yes. Be sure and send us questions or any kind of what you'd like to see. Write to us. Let us know what's going on. And I think I've got everything done. So, talk to you guys later. Bye.